So before we have our lesson for today, let's review first what we have discussed last meeting. As you can see on the board, we have the concept of chance or likelihood. We have discussed last time in our previous topic what a chance or likelihood means. It has something to do with the chances on how the events will happen. Okay? So let's have here an illustration. As you can see, we have 3 circles. How many triangles do we have? 5 and 2 squares. Now, I want you to count how many shapes are there. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the total number of shapes on our illustration serve as your possible outcome. So when you say possible outcome, as you can see on our illustration, it is the total number of possible events that can happen. So in this case, since we have 10 shapes drawn on the board, so meaning to say we have the 10 chances of having this possible event to happen. Now, I want you to get the half of 10. So 10 divided by 2, that will be 5. So why did I ask you to get the half of 10? Because when we get the half of our possible outcome, we can describe what are the chances or likelihood of an event to happen. Remember, we classify them accordingly to these concepts: likely, unlikely, equally likely, impossible, and sure. So let's go back on how we can differentiate those chances or likelihood. So now take a look at our first event. It says there, picking a square. So how many squares do we have on the illustration? So we only have 2. Now, is it more than the half of 10, which is 5? Or is it more than half of our given shapes? So as you can see, it's less than half. So basically, when it is less than half of our total number, it is what we call unlikely chances. Okay? So, unlikely meaning the outcome is less than the half of the total outcome. Now, how about our second event? Picking a triangle or a square. So we have here a triangle and a square. So how many shapes do we have all together? So let's have 1, 2, 3, 4, 5, 6, and 7. So the total number of triangles and square is 7. Now question, is it less than or more than half of 10? Okay, this is more than half of 10. So if that is the case, the opposite of the first one, this chance is likely to happen. When you say likely, it should be more than half of our possible outcome. Can you see the difference between the two? Unlikely and likely. If it's less than half, it's unlikely. But if it's more than half of the possible outcome, it is likely. Now, let me give you another example to differentiate other concept of our chances or likelihood. So let's have an event like this. Picking a circle, triangle, or a square. So what's our event given? Picking a circle, triangle, or a square. Now, how many circles, how many triangles, and how many squares do we have? We have 10. As you can see, it is equal to our possible outcome. that is the case, this event is sure to happen because the total outcome based on the given event is equal to our possible outcome. So that is sure chances. How about the next one? Taking a star. Can you see a star on our illustration? No. Okay, we don't have any stars on our illustration. If that is the case, what kind of chance or likelihood is that? Okay, that is what we call impossible. Impossible means there will be no chance at all for this event to happen because as you can see on the illustration, there is no star. So that is impossible. So we already explained the 4 chances or likelihood. We have likely, which is more than half, unlikely, which is less than half, sure, which is equal to the total outcome, the possible outcome, and impossible, meaning there's no chances at all for this event to happen. Now, the last one is this one. Picking a circle or a square. How many circles do we have on the illustration? So we have 3. How about the square? We have 2. When we combine them together, we get 5 shapes, which is equal to the half of the possible outcome. If that is the case, if the given event is totally equal to the half of the possible outcome, that chances it is what we call equally likely. Okay? Can you see the difference now between the concepts on the chances or likelihood? Remember, we have 5. Likely, unlikely, equally likely, impossible, and sure. Likely, it should be more than half. Unlikely, less than half. Equally likely is equal to the half. Impossible means a 0 chance at all. And sure, which means equal to our possible outcome. Now, let me ask you this particular question. Let me see who is good at imagining things and analyzing concepts. If I will go shopping on Mondays, how many times will I get to the mall for each particular month? Okay? If I will go shopping for every Monday, how many times will I go there on each month? So let's have 1 month here, which is equivalent to how many days? Probably that is 30 days. So for each month, how many weeks do we have? 4 weeks. On each week, there are 7 days. So on these 7 days, how many times Monday will appear? Only 1. So for every week, on each month, how many times will I go for shopping? Okay, it's 4. So we have here 4 out of 30 chances will I go shopping every Monday on a particular month. Where did I get this 30? Because we have 30 days in 1 month. And where did I get this 4? Because there are only 4 Mondays on this 30 given days. So this one is what we call the chances in numbers on how this event will happen. So now, what are we going to learn for our lesson in math for today? So for today's lesson, we are going to understand the link between the chances and probability. Okay, so let me repeat what we are going to learn for today. Understand the link between the chances and probability. When you say link, it has something to do with the connections, the relationship The relationship of what? In this case, we will find out how chances and probability are connected to one another, or simply, how our knowledge in chances will enable us to find out the probability of an event. Last time, I also mentioned with you the term possible outcome and the favorable outcome. So these two important terms are really helpful for us to understand what probability means. So possible outcome and favorable outcome. Both of them refers to outcome. However, they are different in nature. When you say possible, it pertains to the total possible events that can happen. Okay? When you say favorable, it means these are only the wish events that you want to happen. Your wishes only, or the events that you just wanted to happen. So can you see the difference between the two? When you say possible, these are the total in general. In favorable, it means the only wish events, or the events that you just simply wanted to happen. Okay? Now, so how can this knowledge about possible outcome, favorable outcome, and chances can help us understand our lesson for today? So let me have these numbers on the board. So let me write numbers from 1 to 15. Okay, so as you can see, I wrote on the board numbers 1 to 15. So what is the possible outcome? By the way, this PO means possible outcome. What is the possible outcome on this particular number cards? Since we have 15 number cards on the board, basically, that is also referring to our possible outcome, 15. Now, let's find out the different favorable outcome based on the event that we are going to study now. Okay, so in this one, we will figure out what could be the chances in numbers and how can we write that in probability as well. Take note, we are going to do two things. What could be the chances in numbers and what could be its probability. Take note, from our aim, there's a link between the two. Okay? So now, so let's have the first event here. Picking an odd number. Okay, what's our first event? Picking an odd number. So on our given number cards from 1 to 15, what are the odd numbers? Because as you can see on our event, it says here, picking an odd number. So what are the odd numbers on the board? Or on the number cards 1 to 15? So we have 1, what else? 3, 5, 7, 9, 11, 13, and 15. Okay? So, there you go. There are the odd numbers in our number cards. 1 to 15. Remember, the possible outcome given is 15 because that's the number of our number cards. So, what are the chances of picking an odd number on this possible outcome 15? How many numbers did I encircle? Let us count. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 odd numbers between numbers 1 to 15. So 8 is our favorable outcome. So our chances is 8 out of 15. So how did I get that 15 first? This is given already because that's our possible outcome. So where did I get that 8? I get this based on the event given to you. So picking an odd number, so those encircled numbers are considered odd numbers. So that was actually our basis for this 8. 8 out of 15, meaning to say there is only 8 chances out of 15 to get an odd number. So this is how we are going to show an event or chances in number. Okay? Now, what is the probability of this one? 8 out of 15. Simple as this. To write the probability of these chances in number, you just have to write it in fraction. Remember that in fraction, we have the numerator and the denominator. But this time, what are we going to put in the numerator's part and on the denominator part? So we have favorable outcome on top and possible outcome at the bottom. So in this case, 8 out of 15. What is our favorable outcome? 8. So we will put it on top. And then our possible outcome is 15. So this one is the probability of picking an odd number. Now, can we lowest term 8 over 15? Remember on our previous quarters, I discussed with you how to get the lowest term of the fraction. You have to get its GCF. But do they have a common factor? 8 and 15? None. Okay, they are not divisible in one number. So therefore, this 8 over 15 is the probability of picking an odd number. Did you get it? Again, where did I get this 8? From the favorable outcome, or the chances of getting these odd numbers from the whole thing. And 15 is our possible outcome. So this is the chances, and we write that in a fraction form to get its probability. Since it doesn't have a common factor, so 8 over 15 is our probability as the final answer. Okay, now another example. Let's have the second event, picking an even number. If a while ago, we look for the odd number. This time, we have to find an even number. So what are those even number in this number cards 1 to 15? So we have 2, we also have 4, 6, 8, we also have 10, 12, and 14. We already identified what are the even numbers on the number cards 1 to 15. Now, let us express this one as chances in number. So again, take note that our possible outcome is 15. So how many numbers did I box? Because they are the even numbers there. So we have 1, 2, 3, 4, 5, 6, 7. Okay? So we have 7 over, 7 out of 15. Okay? So 7, I get that 7 from the number of even numbers or our favorable outcome. And 15 is our possible outcome. Now, let's write this one in probability. What did I say? We have to express this in a fraction form following favorable outcome over possible outcome. So we have 7 over 15. Now, since it's a fraction, we can get its lowest term. But in this case, do we have a common factor between 7 and 15? None. So therefore, on this particular event, the probability is 7 over 15. Okay? 7 as our favorable outcome, and 15 as our possible outcome. Okay, another example. So let's have picking a number lower than 12. Okay. So picking a number lower than 12. So this is 12, right? So what are the numbers that can be found below 12? So basically it's from 11 to 1. So let us count how many are those numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? So we have 11 out of, what's our possible outcome? 15. So this is the chance in numbers. So what is its probability? So we have 11 over 15. 11 as the favorable outcome and 15 as our possible outcome. Do we have a common factor for 11 and 15? None. So we don't have to get its lowest term. So our probability for this event, taking a number lower than 12, is 11 over 15. Next, another example. Taking a number that is a multiple of 3. Okay, what are those numbers that are multiples of 3? So we have 3, 6, 9, 12, 15. So how many favorable outcomes are there? The multiples of 3. 3, 6, 9, 12, 15. So we have 5. 5 as our favorable outcome out of, what is our possible outcome again? 15. So 5 out of 15. So this is the chances in numbers. How about its probability? It's 5 as our favorable outcome over 15. Now, take a look at that one. Do we have a common factor for 5 and 15? Yes, we have. So how did we get its GCF? Oh, let's go back to our previous lesson. How do we get the GCF of a number? So 5, 15. So divide the larger number by the smaller one. How many 5s are there in 15? So we have 3. 3 times 5, that will be 15. 15 minus 15, that will be 0. So what is our last divisor? 5. So divide both sides by 5, then we get 1/3. So from our event, picking a multiple of 3, the chances is 5 out of 15. And its probability is 1/3. We get its 1/3 because we get the lowest term of 5 over 15. Okay? Another example. Picking a multiple of 5 on the given number. So what are the multiples of 5 there? 5, 10, 15. How many favorable outcomes that we have? 3. 3 out of, what's our possible outcome? 15. So this is the chances in numbers. So what can be the probability for this one? Okay, we have 3 as our favorable outcome over 15. Do we have a common factor for 3 and 15? Yes, and the greatest common factor of that is 3. Okay, so 3, 15 divided by, or divide both sides by 3, that will be 1/5. So our probability for this one is 1/5. Did you get it? Now, what kind of probability did we study for today? Okay, as you can see on those examples, we assume that the outcomes are all equally likely to happen. So this is the basis of the kind of probability that we studied based on our example, that all outcomes are equally likely to happen. We are assuming that all the outcomes given are just equally likely to happen. What do you call that probability? That is what we call theoretical probability. Okay, what do you call that again? Theoretical probability. When you say theoretical probability, it came from the premise that we can assume that all the outcomes or event given are equally likely to happen. Okay? That's what we meant by the word theoretical probability. To make it easier for you to get what this theoretical probability of the given outcome, you just simply follow this formula. So like what we did on our fraction, on top, we have to look for the number of favorable outcome, which is the event or the outcome that you wish to happen only, over the number of possible outcome. Okay? So again, in order for us to make it easier to get what a theoretical probability is of an event, we just simply follow this one. Number of favorable outcome over the number of possible outcome. As you can see, the probability is just written on a fraction form. The favorable outcome should be placed on top, and the total or the possible outcome rather should be placed below. So there are some instances that you have to consider since it's a fraction. Did we have or do we have to get its lowest term? If needed only. As we all know in fraction, if it's necessary for them to get its lowest term, you have to. But if not, then that will be your answer. Okay? So again, when you say theoretical probability is based on the premise that all events or outcomes are equally likely to happen. Or, in short, it can be represented by the formula number of favorable outcome over the number of possible outcome. So you just simply write this in a fraction form with favorable outcome on top and possible outcome at the bottom. Take note that since it's a fraction, you have to get its lowest term if necessary by getting its GCF or the greatest common factor. Let me give you another example. So let's have the word Saturn. Okay? So, how many possible outcomes are there? So, how many letters this Saturn has? So, we have 1, 2, 3, 4, 5, 6. So, 6 as our possible outcome. Now, let's have this event. Picking a vowel letter. Okay, you have to think. Picking a vowel letter. So what are those vowels anyway? So we have A, E, I, O, and U. So in the word Saturn, what are the vowel letters there? So we have A and U. So how many? Only 2. Very good. So our favorable outcome based on the event given is 2. So the chances in number is 2 out of 6. Now, how did we or how can we get its probability? We have to follow the fraction or the formula number of favorable outcome over the number of possible outcome. 2 as our favorable outcome and 6 as our possible outcome. What should we place on top? Okay, so we have 2 because that's our favorable outcome. And what should we place at the bottom? Okay, that is 6 because 6 is our possible outcome. Now, take a look at the fraction. Can we get its lowest term? Yes, we can. Because as you can see, 2 and 6 are divisible by each other or by a particular number. What do you think is the GCF of 2 and 6? So we have 2. So divide both sides by 2. That will be 1/3. So the probability of getting or picking a vowel letter is 1/3. And what do you call that probability again? Theoretical probability, because it came from the premise that all events are equally likely to happen. Another example. So let's have our Saturn again. This time, what is the probability of picking a consonant letter on our word Saturn? So what's the possible outcome again? 6. So that is our possible outcome. Now, how many consonant letters that we have on the word Saturn? So we have S, T, R, and N. So that serves as our favorable outcome. How many? 4. So what is the chances now? 4 out of 6. So there are only 4 chances of picking a consonant letter out of 6. What could be the probability for that? In fraction, following the formula number of favorable outcome over possible outcome. Okay, so we have 4 over 6. Can we get its lowest term? Yes. So what's the GCF of 4 and 6? 2. So divide both sides by 2. That will be 4 divided by 2, 2. 6 divided by 2 is 3. So the probability of picking a consonant letter is 2/3. Okay? So again, let's wrap up all the topics that we have for today's lesson. So we talk about theoretical probability. Okay? So it is based on the premise that all events or outcomes are equally likely to happen. To make it short, how can we get the theoretical probability? We just have to follow the formula number of favorable outcome. What is that again? Favorable outcome? That's the event that you wish or you wanted to happen over number of possible outcome, which is the total possible events that really happen. Okay? So following this formula, we can come up with the theoretical probability in fraction form. And since you have to remember that your answer is in fraction, you have to get the lowest term if it's necessary only. Okay? So using this one, you can also create your own problem. Like for example, if you're about to ask to think of an event that has 1/6 probability, what could be the problem that we can think about it? So, for example, if you have to roll a dice with numbers 1 to 6, how many chances do you think we'll have if you pick a number 1? Since all the dice have 1 to 6 numbers, and there's only 1 there, so it's 1 over 6. Okay, you can also come up with this problem. Okay, so how many shapes do we have? 6. Now, what is the chance or what is the probability of getting a circle from the given shape? How many circles do we have? 1 as in or as our favorable outcome. Our possible outcome is 6. So that will be 1 over 6. Did you get it? So that's how we can represent the theoretical probability. You just simply follow number of favorable outcome based on the event given, of course, over the number of possible outcome. And take note that since it is a fraction, you have to get the lowest term if only it's necessary. Okay? So that's our lesson for today, theoretical probability, which came from the premise that all events are equally likely to happen. I hope you learn a lot of information from our today's lesson in math.